Okay, so we're going to be looking at derivatives, which would be the slope of the tangent line to a function at a point. So here's the problem. Find the derivative of the function by the limit process. The function is t squared minus 5, which is a parabola that has been shifted down 5 units. And then we're going to use that to find the slope at a specific point at 1, negative 4. So first thing to do is we're going to generalize this. We need 2 points to find slope. We're going to do the right-hand derivative. So we're going to take any point t, and when you put the function in, or the input value in, you're going to square the input and subtract 5. So we get t squared minus 5. We need a second point for slope. The second point is going to be the same t value, and we're going to go slightly to the right, just a little bit, like maybe 0.0001 units to the right, so that we're very close to t, but we're going to call that small value delta t, which again represents a very small value. We're going to let delta t approach 0. It cannot be 0 though, because then you would only have 1 point. So anyway, we take our input value, we put it into the function, and then we start doing the slope. Remember, slope is y2 minus y1, y2 minus y1 over x2 minus x1. However, super important, we need to put this limit in the front, because we're going to find the limit as that space between the 2 points goes to infinity. Now, if you put 0 in for delta t, you're going to end up with this going away. You're going to get t squared minus 5 minus the same amount, which is 0. And then if delta t is 0, then we end up with t minus t, which is also 0. So we need to do some algebra. So here's where you have to be like a surgeon. You're going to need to expand this out. So it would be t plus delta t times t plus delta t. Use the FOIL method if that helps, first, outer, inner, last to distribute. Being very precise. And then be careful with this negative here. Big mistakes happen with negatives. Minus t squared, but minus a negative 5 is a plus 5. You should see some values dropping out, which they do. Negative 5 and positive 5 drops out. The t squareds drop out. We should get a much simpler function now. We're left with these two terms, which can be factored. I can take out a delta t from both of these. And then the delta t's divide out. And we're almost there. Let delta, now we can try direct substitution again. The delta t goes to 0. We end up with 2t. So we have a formula to find the slope, 2t, at any point on the function. So if we want to find the slope of the original function, t squared minus 5, at the point 1, negative 4, we can put 1 in, and we find out the slope is 2. And that looks pretty reasonable. Up 2 over 1 is the slope of the tangent line, which is also known as the derivative, the rate of change. So at this point on the graph, the function is changing at a rate of 2 units per x value units. We really need it to be a real-world problem to have that make a little more sense. Okay, this is kind of out of my screen, so you'll have to do this on your own. You're going to go to this link, you're going to change the a value to 1, and then you can see what the slope is. Okay, so now you'll do the homework, which is listed on Google Classroom.